how do you look at India's steps in AI? India wants to take a leadership position. It has made it very clear. It is taking, all of those measures like, having the India AI initiatives rolled out, a 2.0 and the next version already in the works. Where do you see India's progress so far as, this technology is concerned?
I think AI is many different things. It is the ability for us to democratize expertise. It is the ability to sort of tackle problems that we have not been able to solve till now. So, to give an example, in democratizing expertise, healthcare, high quality, reliable healthcare. This is a challenge that many countries are facing around the world, including India. How do we make sure that Indians, the 1.4 billion Indians, have access to high quality healthcare? This is where AI comes into its own and can be used as the democratization force for bringing in knowledge and bringing in information about not just healthcare, about agriculture, about energy, about so many different things to the population. And then there is the second part, sort of the part which goes beyond providing just expertise and unlocking new things, new treatments for diseases, new sort of accelerating drug discovery, coming up with new materials that can help us deal with energy issues that we are sort of facing as a species. So, the opportunity for India is in both these spectrums, in democratizing expertise, but also really tackling and pushing the boundary in terms of science and really making progress on these very important challenges.
Right. You talked about talent, and I want to bring your voice in on this. India, of course, has a strong base of STEM talent. From a research perspective, where can India meaningfully contribute to global frontiers in artificial intelligence, not only for its own healthcare and agriculture? Can it contribute meaningfully to, say, foundational research, applied innovation, and deployment of scale? Deployment of scale, by the way, we have done very successfully in DPI as well.
Yeah, so I think India has amazing talent. Its educational systems are extremely strong. They have produced excellent researchers, engineers. In Google DeepMind, we have one of our key labs in Bangalore, in India. And that lab has contributed and made fundamental sort of contributions to our foundational models and to applications of AI in various important sort of fields. So, I think Indian talent has a very important role to play in the future of AI, both in the development of core machine learning and AI technologies, but also more importantly, how those technologies manifest themselves in important tasks, whether it's in agriculture, whether it's in healthcare, whether it's in sort of understanding of social systems. There are a lot of things that Indian research institutions and researchers and engineers can do.
What is it that excites you the most on application of AI in science? And really take us through your own field of expertise on how Google is using AI in science.
Yeah, so our approach has always been to really show what is the promise of AI in science, and we started our journey with this grand challenge problem of protein structure prediction, which is one of the key challenges in biology. So why is this problem important? Proteins are the building blocks of life. You and me, the fact that I'm speaking and the fact that you are able to hear me and make sense of it, it's all proteins in action. This is what makes life work. And yet, as a species, as a scientific community, we were not sure what do they even look like for the majority of the proteins. And with our breakthrough model AlphaFold, we were able to shed light on this protein universe and not only make this scientific advance, but also democratize it. there are 3.3 million people, researchers, who are using this tool. Earlier, they did not have access to this tool. 1/3 of them are in low and middle income sort of countries. 180,000 of them are in India. There are 180,000 Indians, researchers, who are using this AI model to find new cures, to figure out and develop new crops that can be resistant to disease. There are so many things that Indian researchers are doing with that technology. Now, my sort of role now is to replicate that progress across many other fields of science. So, not only to revolutionize biology and help AI and show where AI can sort of have impact in biology, but also sort of show what AI can do for material science, for enabling fusion research, for enabling quantum computing. So, these are the hard sort of challenges across basic sciences and mathematics and computer science that Google is working on, and then sharing those models with the world and with scientists across the world.
Help me break this down for the general public on what the impact of this, significance of this really is. When you look at AlphaFold and what it enabled in a conventional or legacy system, how long would these progresses, these steps have taken had it not been for an AI, an AI interface or an AI diffusion in it? What did AlphaFold enable us to do that was not possible with the previous versions of technology that we were using, and how did it affect our day-to-day lives?
Yeah, so suppose you are a researcher who is trying to develop a treatment for a neglected tropical disease like Chagas or leishmaniasis. Most of these sort of the mechanisms of these diseases sort of require you to understand interactions of proteins, because proteins are as I mentioned, was the building blocks of life, right? This is also the same. This is also the case for SARS-CoV-2. So in COVID, the interactions, the fact that basically the spike protein of SARS-CoV-2 sort of interacted with the ACE2 receptor. It's also about it was also a protein sort of interacting in that case. So in order to study these things, you need to be able to understand the structure and the function of these proteins. So that particular researcher in India or in a rising middle income country did not have access to the laboratories that could come up with this structure. And even if they did, they would require millions of dollars and sometimes millions of years. Now those researchers can do it as for free on in one click.
That is what you meant by democratization
exactly.
of technology.
Yeah.
Okay. Was that, according to you, the biggest scientific breakthrough in AI in the past few months and years? Would you qualify that as being one of the biggest?
Yeah, so I think it has definitely been the one which has had the largest impact till now. The fact that 3.3 million people are using it is a testament to that, and like the scale of applications is also evidence for the impact, and of course being recognized by the scientific community by the Nobel Prize that Demis and John that were part of the AlphaFold team, and was a great honor. But if you look at what science is, where AI is going and where AI for science is going, what we are seeing is that we now are entering the world of agents. AI agents which are really helping scientists solve difficult problems across the whole spectrum of different topics, not just in biology, not just in material science, many, many different things. And so that's also a very exciting sort of a thing that is emerging in AI today.
When we think of AI, we tend to oversimplify it in terms of Gen AI, perhaps because that is the interface that we see immediately. Google DeepMind has worked on AI for protein folding, climate modeling, and complex problem solving. Are we entering the era in which AI's biggest impact will be on science and not consumer tech?
I think the impact of AI will be in all these sort of areas. It will make generally people more productive. Um, it will sort of, as I was mentioning, expand expertise like in healthcare, in many other sort of areas where deep expertise is required. But at the same time, science is going to be one of the key applications of AI as well. And it will really show what is possible in terms of what scientists can do in leveraging the data that they have and using this technology to reason with that data to come up with new insights. We all sort of, many of us have seen those matches that AlphaGo played with the Go champion Lee Sedol, and the reaction to that move 37 of AlphaGo, where it had discovered a new move in Go, and at first we thought, well, this might have been a mistake, but it turned out to be sort of an amazingly insightful move. I think we are seeing that moment now coming up, and we are revisiting that moment in many areas of science. We will see many move 37s in biology, in chemistry, in many important applications that we care about, in energy production, in sort of how do we deal with climate change. So I think that's what's happening.